Hello, calculus fans. Let's talk about tangent planes to level surfaces. So let's suppose we have a surface with equation f of x, y, z equals k. And the important thing to see here is that we're going to interpret this as a level surface of a function of three variables. And we're going to let p, x naught, y naught, z naught, be a point on the surface. Now we'll let C be any curve that lies on the surface S and passes through the point C. And remember that a curve C will be described by some continuous vector function r of t with components x, y, and z. Now let's let t naught be the parameter value that gives us the point P. In other words, we'll think of this as being r of t naught equals x naught, y naught, z naught. Now C lies on the surface, so any point must satisfy the equation of S. That is, we can say that f of x of t, y of t, z of t equals k. And we'll just assume that x, y, and z are differentiable functions of t, and that f is differentiable as a function of three variables. Now let's use the chain rule to differentiate both sides, and we'll get something that looks like this. df by dx times dx by dt plus df by dy, dy by dt plus df by dz, dz by dt, that equals 0. Now we know that the gradient of f is equal to fx, fy, fz, and r prime is equal to x prime, y prime, z prime. So really we can rewrite this whole thing as just being del f dot r prime equals 0. And when t is equal to t naught, we know that r of t naught is equal to x naught, y naught, z naught. So now we can say that del f at x naught, y naught, z naught dotted with r prime at t naught is equal to 0. Here's the important thing that we're getting at. This tells us that the gradient vector at p, which is del f at x naught, y naught, z naught, is perpendicular to the tangent vector r prime at t naught. And that's for any curve on S that passes through the point C. So as long as that gradient vector is not 0, we'll define the tangent plane to the level surface to be the plane that passes through P and has normal vector del F. And now we can use the standard form of the equation of the plane to write down an equation of this tangent plane, and it looks like this. So the fx, fy, and fz give us the components of the normal vector, and x naught, y naught, z naught are the coordinates of the point that we know that's on this plane. Okay, that's all for now.